Hi everyone, so today's lesson was over reviewing how to simplify radical expressions. Remember, a radical is another word for a square root. And this is just to get us started into what we're going to be learning next, which is going to be the Pythagorean theorem. And in order to find our answers for the Pythagorean theorem, we're going to have good simplifying skills for our radicals. And so let's get started. Just a little disclaimer. If you have another way to simplify radicals that you've learned in the past, whether it's birthday cake or splitting up your factor trees, then by all means, stick to that method if it works for you. This is just another way of simplifying radicals that's a little quicker, and sometimes it's a little easier for some people to do it this way. So let's get started. We first start by identifying our perfect squares. So a perfect square is consisted of when you multiply two numbers, the same number by itself twice. That is where the word squared comes from. So 1 squared is 1. 2 squared is 4. 3 squared is 9. So far, these are the first three we've done. Our perfect squares here so far are 1, 4, and 9. And if you're wondering what makes something a perfect square, well, it's literally that. A square has to have the same length on all 4 sides. So if I draw this square and this side is 3, that means all the sides have to be 3. Okay, and whenever you find the area of this square, 3 times 3 is 9. So that's why 9 is a perfect square. Okay, so let's keep going. 4 squared, some of you already probably know these. 16. 5 squared is 25. 6 squared is 36. And of course, if you're in my class, I don't expect you to have these memorized. It's good to identify them, and you'll see them, start to recognize them more. But if you forget them next week, that's fine. It's not a big deal. Most likely you'll have a 4-function calculator to help you. But these are just from 1 through 12. And we're filling this in just so we can see the numbers, okay? So all of these are my perfect squares. 1, 4, 9, 16, 25, 36, 49. All of these right here, okay? And I could keep going. 13 squared, 14 squared, it keeps going, right? But now let's go backwards. So the opposite of squaring something is to square root it. The opposite of squaring is square rooting. So what is the square root of 1? 1. What is the square root of 4? What two numbers multiplied by itself, by itself, gives you 4? 2. Square root of 9, 3, 4, and if you notice the pattern, we're just going to write them all the way down. 8, square root of 81 is 9, square root of 100 is 10. You take the square root of 121, it is now 11. There's a typo. And 12. Okay? So we're doing this because we cannot leave our square roots like this, okay? You have to simplify it. So the square root of 144 is 12. But sometimes we don't have perfect squares that you can take the square root of. And so that's why we have to simplify it as much as we can. So let's get started with some vocabulary. A radical expression which contains a root. That is what it is. So here we have the radical. That is this symbol right here. And then the number inside, we call that the radicand. Okay. Now, a square root or a radical is not simplified unless it has these 3 conditions. Okay. The radicand contains no perfect square factors. Okay, so what does that mean? If it's a number like 36 or 45 or 28, those contain factors that are perfect squares, and we can't leave them like that. It's not simplified enough. The radicand is not a fraction, so you cannot leave it as a fraction. There are no radicals, so we cannot have square roots or radicals in the denominator of a fraction. Okay? And we're going to learn how to get rid of it if you do have a square root in the denominator. So what does that mean? If I have something that looks like this, 1 divided by the square root of 2, that is illegal. You can't have that. And so this is not okay. And we're going to learn how to undo that. Okay, so let's keep going. Let's start by simplifying this one right here. Square root of 24. I'm going to copy my perfect squares over to the next page, just so I can have them in handy over here on the side. Okay, so there are my perfect squares. Now, if you like birthday cake, you would do this by dividing prime numbers into 24. So you would start with 2 and then keep going, and you end up with a candle. You group your pairs. These are your singles. You set up your house, your one pair of 2s on the outside, a single 2 inside, and a single 3 inside. And that simplifies to 2 square root of 6, okay? Now, I did that pretty fast. But if you know that the birthday cake takes too long for you, or you get confused on what to pair or anything like that, it's okay. I'm going to show you this method. So it says, find the largest perfect square factor of the radicand. So who is my radicand here? My radicand is 24. Who is the largest perfect square that will divide into 24? Now, the key word here, it has to be the largest perfect square. So the greatest number that is a perfect square that will divide into 24. Which one do y'all think? If I look at this list. A good thing to note is that you want to start with numbers that are less than 24, because obviously if you do 25, that is going to create a fraction. So we don't want that. So let's start with 16. Do you think that 24 divided by 16 will give you a whole number factor? And the answer is no. What about 9? 24 divided by 9. No, not in this world. What about 4? Yes, 24 does divide by 4. So then we would rewrite 24. That's step number 2. Rewrite the radicand as the product of those factors. So that would be 4 times what? 24 divided by 4? What is the other factor that'll give me 24? If you don't know, you could use a calculator. Not against calculators. 24 divided by 4 is 6. Okay, so let's go back. 4 times 6. And then the next step we want to do is simplify by reducing that perfect square that we found. Who is the perfect square? The perfect square here is 4. So we want to separate the radicals, because we can do that since they're both under the radical. They're both square roots. And then we want to simplify that perfect square. What is the square root of 4? If you want to go back to the front, we had it right here. The square root of 4 is 2. The square root of 4 is 2. And then the 6 cannot be simplified any further. It's already as simplified as we can get it. So that is our answer, final answer. And notice how we ended up with the same answer as the birthday cake if you like birthday cake. See? Oops. Right here. Okay, and that is how you simplify radicals. Now, let's move on to that very illegal thing that we cannot have. We cannot have a square root in the denominator of a fraction. So the way to undo that is called rationalizing the denominator. And the way you do that is you take the square root that you have in the denominator and you multiply the numerator and the denominator by that same square root. So see how this one, square root of 5 here is in the denominator. So I'm going to multiply the numerator and the denominator both by the square root of 5. And that is literally what rationalize means. So if you want to write that word here so you don't forget later, this is you rationalizing. Now, what do we do next? We multiply across. What is 4 times the square root of 5? You can't put them together because 4 is a whole number and the square root of 5 is a square root. So let's just stick them together. I know it looks weird, but just leave it like that. And then here in the denominator, we can multiply both of those because they're both square roots. So 5 times 5 is 25. Okay, but this doesn't solve anything yet. I still have a square root there in the denominator, and that's not okay. So what did we do? What do we do now? If you notice, 25 is a perfect square. We made it that way. We made it by multiplying 5 twice. Do you see that? So since 25 is a perfect square, we can take the square root of 25. That is a perfect square radical. So what is the square root of 25? Well, the answer is actually right here. It was 5. We multiplied 5 twice. So now the fraction is simplified. Okay. All right. So for you, you have 6 problems to work on. You can work individually or with a partner or come see me if you need help. But these 6 problems, you should be able to do all of them. The first 4 are going to be just simplifying the radicals. There's no fractions. But these last 2 are you rationalizing. So that is what we did here, getting rid of the square roots in the denominator. If you want to go over your work and see if you got these correct, check with me or watch the other video where I go through each one of these. Okay, thank you. Have a good day.